You've probably heard this one before. If the form, fit and function are the same, the part number doesn't need to change. Hi, I'm Darryl Frank. I'm a principal systems engineer with over 25 years experience in military aircraft weapon systems integration and certification. I even wrote a book called Requirements to Reality to explain this exact mystery. It's one of those phrases that gets thrown around a lot in engineering meetings. But what does it really mean? And is it actually true? Especially in aerospace, where every part number can tie directly to certification and airworthiness. So let's unpack this from both the developer's point of view and the customer's. Let's start with the basics. Form is what the part is physically. Its geometry, dimensions, weight, material, finish, everything you can see or touch. Form is what the part is physically. Its geometry. If you're holding it in your hand, form is everything visible and tangible. Fit is how that part interfaces with the rest of the system. The bolt patterns, the electrical connectors, the alignment features, the tolerances. Even if two parts look the same, if one of them doesn't slide into place properly, the fit has changed. And function? That's what the part actually does. In an avionics module, it could be the data processing rate or the communication timing. For a mechanical part, it may be the load it carries or aerodynamic performance it delivers. But here's where a system engineer starts to ask deeper questions. Because in reality, form, fit and function aren't defined by what we see, they're defined by the requirements. From a systems perspective, the requirements tell us what matters. They include the functional, safety and certification requirements, the things that must not change if we're to claim that two parts are equivalent. Let's take a simple example. By definition, color is part of form. But unless the color is specified in a requirement, say for visibility, safety or thermal control, then changing the color has no effect on the defined form, fit or function. So two parts, one blue and one gray, might share the same part number. On the other hand, if you change the material, even if everything else looks identical, you might alter structural strength, electromagnetic performance or flammability. That's a functional change, and now we're in new part number territory. A part number is more than just a label. It's a key that links everything about the design, drawings, bills of material, inspection processes, test data, and certification evidence. For a developer, that number maintains config control through design and production. It's how we know which test results will apply to which design. For a customer, especially in aviation or defense, the part number is a guarantee of equivalence. When they order that part, they expect it to fit exactly in the same space, perform in the same way, and meet the same airworthiness requirements. Changing the part number tells the world this is no longer exactly the same part. In aviation, components are certified by part number. Every part number forms the part of the type design or supplemental type certificate. So when you change a part number, you're signaling that the certification dataset might also need to change. If the modification is insignificant, meaning form, fit and function are unchanged, then your existing certification basis often still applies. But even if one of those aspects changes, especially that's something that affects safety or performance, you likely need new tests, new documentation, or even a new approval. That could include environmental testing, like DO 160, software certification under DO 178, or new instructions for continued airworthiness. Certification authorities don't take minor changes lightly. So let's talk about how to tell the difference between significant and insignificant changes. Insignificant changes are those that don't alter form, fit or function as defined by requirements. For example, changing the color for aesthetic reasons, minor documentation corrections, process updates that don't change tolerances or materials. These are handled through revision control within the same part number. And it's important to note that these are specifically for internal manufacturer's configuration management. It should have no effect or require any changes to the customer's documentation. So the parts catalog should not say install mod 1 or mod 2, as this would indicate a significant difference. Significant changes, on the other hand, are anything that affects interfaces like bolt holes, connectors or alignment, performance, speed, accuracy, environmental limits or safety. Anything that affects certification or reliability. Once you cross that line, you're into new part number territory. It's a formal acknowledgement by the manufacturer that this part is not interchangeable with its predecessor. From a systems engineering point of view, the key question when evaluating a change is simple. Does this modification invalidate any allocated requirement? If the answer is yes, it's a new part. If not, it may just be a revision. That's why many organizations have configuration control boards, or CCBs. They bring together engineering, certification, quality, and customer representatives to make that call objectively. The goal isn't bureaucracy, it's traceability and accountability. When every part number is tied to its design intent and certification data, you preserve the integrity of the product, the customer's trust, and ultimately the safety of the system. So the next time someone says the form, fit, and function are the same, you don't need to change the part number, remember it's not always that simple. Form, fit, and function are defined by requirements, not just by what you can see. A part number just isn't an internal convenience, it's a contract that ties together design, manufacturing, and certification data. Change it too casually and you risk breaking that change of evidence. Fail to change it when you should and you risk misleading your customer or even invalidating certification. Form, fit, and function are simple words, but in systems engineering, they carry serious weight. Check the description for the link to my book, Requirements to Reality, which explains systems engineering in simple language.